My name's Dennis Redwine, and my brother and I have founded a company called AI4Cloud. We're bringing artificial intelligence, actually cloud-based enterprise infrastructure monitoring, leveraging artificial intelligence for public, private, and hybrid clouds. So we started this business a couple of years ago, and what it does is basically bring next-generation enterprise-class monitoring technology to medium-sized businesses. One of the challenges that businesses have with today's technologies is the complexity, the dynamic nature, and the scale is growing to the point where a lot of customers are investing their money and time in provisioning applications, DevOps, next-generation technologies. But one of the pains of these new technologies, bringing them on board for customers, is operationalizing that infrastructure, helping the business understand how that infrastructure is driving the business, how it's serving the business, and how the health of the applications are serving the business. Are they at risk? What's the availability? Who's affected? DevOps doesn't provide that. Provisioning doesn't provide that. Service catalog-based implementations of private cloud don't provide that type of monitoring. So, as an example, in the past, I think you could, consider that the technologies from 10 or 15 years ago, you could divide them into three broad categories. You had the infrastructure layer, services, or servers, switches, routers, load balancers, etc. And you had the application layer. You had clustered applications and application relationships between the applications in that layer. And they were subtended by that infrastructure and depended on that infrastructure. But ultimately, they were driving the business. So in terms of driving the business, the difficulty is in understanding how is that underlying infrastructure, the physical and logical infrastructure, and the application topology, how is it driving and supplying that business? Well, one of the other things that's happened is that's an old model from, say, 2005, but what's happened today is that model has grown in complexity and scale. So today you have the physical storage topology, storage area networks, but you also have the physical networking topology. You have logical networking like OSPF, BGP, MPLS layers. And then layered over that, you have virtual networking for provisioning activities like VMware, et cetera, in terms of the private cloud. And layered over the top of that is the physical compute topology that supports the virtualized infrastructure, whether it's software-defined networking or topology that supports the application layer that ultimately supports the business. Now, the business, they're trying to run applications, whether it's advice and planning tools for a bank or X-ray imagery for a medical facility. They care about the business. And the difficulty for customers these days in terms of complexity and scale of managing the underlying infrastructure is understanding how this impacts that top layer of that business. So companies go out to suppliers like IBM, HP, CA, etc., and purchase enterprise class applications that require potentially years of infrastructure development to get that woven into their infrastructure fabric so that they can have that type of telemetry to understand how the infrastructure is serving the business. Well, what we do is we bring that type of sophistication to medium-sized businesses by offering that as a service. We offload the complexity, we offload all of the implementation, because we simply deliver that service to the customer either via VPN or a direct connect. We have all of the infrastructure, including the artificial intelligence semantics that understand the behaviors of those objects and how they affect the business in our own facility. So we simply connect to the customer's infrastructure. We do all the pinging and polling and discovery for that infrastructure and use that information to build a semantics-based topology model that has not just like in a SIM model where you would have objects with relationships and attributes, but included in that model are behaviors and symptoms and problems and their causal propagation to their neighbors, such that we can understand how those objects impact the business in terms of either risk or performance or availability. So we bring that information into our cloud. We have a variety of colos, including CenturyLink and Verizon. And process that information, and then deliver back out to the customer that enterprise class information in terms of reports and availability and business level reports as well as the underlying reports. Now, one of the interesting things is that customers still have, even in that model, they're going to have element managers that manage storage. They're going to have element management systems that manage the network, the virtualization layers, depending on which vendor you pick. But at the end of the day, the problem is that the business, right, needs to understand how that infrastructure is supporting their business processes and applications. So by offloading that complexity, not having server administration, network administration, security administration, application training is the only thing they have to do, is that top-level application training to be able to use our application, and they get that enterprise class service. So it's like a ServiceNow or a Salesforce.com is software as a service, but it's enterprise infrastructure monitoring, leveraging next generation artificial intelligence. And I think in terms of our addressable market, because we're focused on the cloud space in terms of public-private infrastructure, we can manage and monitor Azure, AWS services, as well as the private infrastructure, and make it look and seem like a single holistic system that reports on the status of the infrastructure in the context of the business. So these are our two really main areas of interest in where we're playing, is the private cloud, hybrid cloud, and also public cloud. And I think that's it.
So I guess the question is, are you looking to investors or hire anybody?
Oh, yeah,
or?
thank you. Yeah, so we're looking for two things. Yes, we're looking for investors. We're also looking for customers. We're a small startup. The underlying technology that we use is an acquisition by Dell. When they purchased EMC, they purchased some technology that's applied to large organizations. The Fortune 50 uses this technology. AT&T, Verizon, BT, Infonet, Orange. Around the world, the largest, most sophisticated networks and systems use this particular artificial intelligence technology to understand problems at scale and arrive at a root cause determination so that they can put the right person on the problem and notify all the affected stakeholders in real time when the problem occurs. So we're looking for two things: investors to grow the company, and we're looking for customers, mid-sized customers that are interested in getting better control on their infrastructure in the context of their business.
How personnel intensive is your onboarding process? How many people and how many man hours?
In general, we've been doing this over for a couple of years. We normally only have one guy per customer, even for large customers, for up to, say, 15,000 devices, in that range. We can handle that with one administrator. So it's a very scalable solution. It requires very little administrative overhead. Because one of the things that we've done is we've taken this enterprise class software that we spent 20 years in the industry running for companies like EMC, AT&T, CompuCom, Dell included. They've used this software as well. So we have that intellectual property in terms of how to manage that application efficiently and effectively and deliver good value to the customer. We have a scalable model. Basically, we just have a cookie cutter of an application that's dedicated for each customer, because when you connect into the customer's network on a VPN or a private connection, you need to be able to guarantee them that you have isolation on the back end for all of their services.
Okay, so it sounded very complicated in terms of your presentation. So essentially, what is the goal of your AI4Cloud? Because I sort of lost.
What it does is, so one of the problems that businesses have is when problems occur in the infrastructure. This is a simple example. When problems occur in this underlying infrastructure, so you have a problem with a storage device or a network, or a server has either CPU utilization problems, memory problems, variety of problems that the server could have or the underlying infrastructure could have that would affect that application. Well, you don't want to alert both the application owner and the server owner and the network owner and the storage owner and the business owner to say, hey guys, let's get in the war room and figure out what all of these symptoms mean. You want to say, oh, the problem is this cable connection, right, to these redundant switches that supports these dual home servers, that runs the finance application, that supports this business. So you get three things done. One, you can run the infrastructure in the context of its impact on the business, but you can also provide the root cause message to the responsible party at the exact same time that you deliver symptomatic messages to the stakeholders so they can take appropriate action if they need to, but recognize that the problem is not in their finance cluster. The problem is in an underlying component, and that somebody's working on it.
One more question.
Yeah. So you obviously know the problem really well because I did not understand half a word, but that another thing. But you love the problem, you know it really well. But you mentioned something that only takes one person to service 15,000 devices, right? And that's a big value add. So is it also cheaper? Does it also take faster? If you put those things in the presentation, then it will just be a complete selling package.
Well, great. I'm glad you mentioned that. As one thing I was remiss in mentioning is, so the price to acquire the functionality through us is a fraction. It's 20% of an enterprise class application, just the purchase of the software itself. So when you think about a business that's got to implement servers, virtualization technology, deploy the application, manage the security and the network and the servers, as well as the application, and train their people, we offload all of those infrastructure elements. The only thing that they're left with is training the operators to manage the console.
And I believe you because how you do the presentation, we can tell that you're a credible source. So if you just tell
Thank you.
me you're better, we'll believe you. So just yeah, seriously, say we're cheaper, we're better, faster.
We are cheaper, better, and faster.
So
You get all
yeah.
three, not just two of the three. So that's true. Yeah. Any other questions? Yes.
Do you also have any kind of security and artificial intelligence, or is it only for network and common problems like cables, devices fail?
Glad you asked that. No, it extends into storage, goes across. It's all of the infrastructure elements. It's not security specific. So it doesn't have artificial intelligence around security objects. The semantics are constrained semantics. You know, when you think about something like Big Blue, the semantics in a artificial intelligence engine are around language and the meaning of language, which is what semantics is. It's the discipline of meaning, right? Well, the meaning in our semantics model is around object behavior. Cables, ports, CPU, fans, applications. Is the application process running? If the application process isn't running, why is it not running? Did it bend because it couldn't get to its storage resource? Right? Did it have a problem? Did it have a congestion problem on an interface that caused a memory issue, that then caused a CPU problem, that caused a slow application, or a degraded application, or a malfunctioning application as a result of the dependencies and the causal propagation of the problems through the topology. Yeah, and it goes all the way from the application, all the way down and through out to storage, across the network, and to other application components.
So it's kind of like there's other like Dragnet or for Dell or system support, right?
It's an infrastructure monitoring tool, but it has artificial intelligence to understand the root cause problem and separate it from the symptom events. That's a major difference if you look at almost any other platform in the marketplace except this one. They don't have the artificial intelligence to separate symptoms from problems, or the intelligence to also understand how that impacts the business, because they don't have the semantics model to describe the behaviors, or a way to connect those elements together, or a way to get the computer to understand the semantics model. So if you think about it, if you took a semantics model or a SIM model and you put it in a database and it said this object has these attributes and is connected to their neighbors, that database can't think. It can show that information and it can show the change of status, but it requires humans to process all the data. In our case, it does understand those attributes and those behaviors and their causal propagation because it has a unique patented method to turn that semantics model into a table space a computer can understand.
Okay.
Yes, sir.
We got to move to the next one because we're almost
great.
out of time. Sorry.
Thank you.
Follow up the
Thank you,
questions.
guys.
Thank you.